Today we're going to be working through some practice problems on constant acceleration. So when you do constant acceleration, there are different variations of the equations. If you have a constant acceleration, all the equations can be written probably in the simplest form like this. VF, mean final velocity, equals initial velocity plus acceleration times time. VF squared equals initial velocity squared plus 2AD. D, or displacement, equals initial velocity times time plus 1/2 acceleration times time squared. Now these three equations are referred to as the three equations of kinematics. And as long as you're under constant acceleration, these will hold true every time. So now what we want to do is we want to read the question and write down our givens. Typically we read the question 2 or 3 times. I'm just going to read it once. You're given the initial velocity, so we write down our givens. We have the initial velocity. It doesn't give us a number, but we know we have it, of an object at time t equals 0. The velocity of the object at a later time t, so we have the final velocity of the object. And the time interval, so we have the time interval that this happens, in which this change in velocity occurs. Assuming constant acceleration, we don't know what the acceleration is, but we assume it's constant, so that means we use these three equations. Which equation can be used to find total displacement? So we do total displacement equals question mark of the object from time t equals 0 to time t. So now we have to rearrange these equations to solve for displacement only using these variables. And we have a constant acceleration in there, so that's how we know we can use these equations. So let's go ahead and start with, and what you want to do is you just want to pick one. Since I have initial velocity, which is in this one, final velocity, which is in this equation, and time, I'm going to use this equation here. So VF equals VI plus AT. Now I have every single one of these except for the acceleration. So I'm going to solve my equation for acceleration. And then what I'm going to do is I'm going to plug in the acceleration into one of these other equations over here to solve for my displacement. So I do a little math. I get acceleration equals final velocity minus initial velocity, because I subtract this over, all divided by time. That's my acceleration. So now which one of these remaining equations is easiest to find displacement? I can find it in either one because I have displacement in either equation, but this one's the easiest. It's already solved for displacement. So I'm going to say displacement then equals initial velocity, which we have, times time, which we also have, plus 1/2 a. Now instead of putting acceleration, I'm going to put this acceleration in. So this goes in here. So that's final velocity minus initial velocity divided by time. And then it's times time squared. Now we just do some algebra to consolidate. So this time squared is going to cancel with one of those. So I'm going to get D equal to VIT plus 1/2. I'm going to multiply that in. So it's VF times T minus VI times T. And so I'm going to continue. Let me move the camera here. Displacement equals VIT plus, now I'm going to factor that out. So 1/2, or factor it in rather, minus 1/2 VIT. So I have a negative 1/2 VIT. I have a positive VIT. So these two are going to combine to give me a positive 1/2 VIT plus 1/2 VFT. That's going to equal my displacement. Now that is the correct answer. However, a lot of times when you're doing a multiple choice assessment, it'll be written different ways. So it could be written like this, where they take the T out, and then you end up with VI plus VF, sorry about that, all divided by, and there's your half. Probably how it's written, but it just depends. It could also be written, instead of calling the D for displacement, it could be written as X, or position final, minus X initial, which is the final position minus the initial position, which by definition is the displacement. So it could be written like this, plus VF over 2. But whether it's written this way, or this way, it doesn't matter. It's all the same thing.